Hello everybody out there. Welcome back to the RostyMaths channel and welcome to this brand new video on circle theorems. Now, before I get going, I'll apologize straight away. This is going to be a long one, but you already knew that because you saw it in the video description. But if you're looking for a particular part of this video, here is a handy little contents of where you're going to find those bits. You can also find that in the description. Anyway, without further ado, let's jump into the lesson. Okay, so in this video, before I get going, there's some prerequisites, some things you must know before we get started. And one of the first things would be the keywords that I'll be using. And when I use these keywords, you need to know what they mean. So let's start first of all with some of the words we have got here. Tangent. Well, a tangent is basically a line that just goes past the circle and touches it. So this is my tangent. Okay, the next word I will tell you about is a chord. What is a chord? Well, a chord can be easily mistaken for some other bits and pieces, but let's actually start drawing one here. That is a chord, and you know a chord because it goes straight through the circle, just touching the circumference here and the circumference there. And that also tells you what the circumference is, because the circumference is the distance around the circle there. Let me write this word chord in the circle. So this is my chord. Now the chord is very different from the diameter or the radius. So we're going to now show you, I'm going to now show you what the diameter or the radius is. So I'm going to start by putting a center in there. If I pull a line that goes straight across and it goes through the center of the circle, so long as that line goes through the center, this is called a diameter of the circle. Now, and that takes care of our diameter there. So I told you what a chord is, what a tangent is, told you what a circumference is, and the radius is half of the diameter. So just from there to there would just be my radius. So now you know what the radius is. The next thing I'll tell you about is an arc. If I cut off any part of that circle there, which is what I'm going to do now. So I'm going to cut off a bit of the circle like so. Once I cut that bit off, this piece that I've cut off there is called an arc. The arc is any part of the circumference of the circle. So this is the arc there. So now you know what the arc is. And finally, the segment. What is the segment? Well, the minute I draw a chord into the circle, it divides the circle into two segments. This whole section here is called a major segment, and this little piece here is called a minor segment. So, and you can also get two equal segments by drawing a diameter straight across the middle. And that's what the segment is. So now you know the key words. Let's go now into understanding the rules, of which there are 7 I'm going to tell you about today. Okay, and then once we've done the rules, we're going to show how these work in a few GCSE questions, and that is what makes the video a little bit lengthy. The first rule for circle theorems says that angles in the same segment are equal. What does that mean? Well, what it means is this. I'm going to quickly stick a segment across the circle here, and I'm going to make a series of angles inside of that segment. So if I make an angle up here, like so, and I'm going to call this angle here theta. So let's call that theta there. And then if I decided to make another angle in that same segment, then this angle here, theta, is exactly the same as that angle there. So as many angles that I make, so long as it originates here and there, and I make more angles in there, all of these angles are the same. And that's what that rule means. Now we go on to the next rule. And the next rule says that the angle at the center is twice the angle at the circumference if it stands on the same arc. So again, I'm going to identify, let's identify the center first. So here's my center here. And then what is this rule really telling us? Well, it's telling us that if I have an angle at the center and I also have another angle at the circumference standing on that same arc, then the angle at the center is double the angle at the circumference. So where is my arc? Well, this is the arc that it stands on there. And so what this rule is telling us is that whatever the angle is up here, let's call that theta again, then the angle in the middle is 2 theta. So this angle in the middle is always double that angle up there. And that's the second rule. The next rule now says angles in a semicircle are right angles. Right angles means 90 degrees. So these are 90, let's change color. These are 90-degree angles. That's what right angle means. So what does it mean now? So for this one here, I am going to draw a line going straight across the center. This is my diameter, and let me put my center in to show you that I do mean diameter. Now once you draw a line straight across there, it cuts the circle into 2 semicircles. So you got a semicircle at the top and a semicircle at the bottom. This rule is saying that any angle you make inside of that semicircle is always going to be 90 degrees. So let's make one and show you. And I know I'm using the language quite loosely, but I do want you to make sure that the angle is touching the circumference, okay? This is not a very good example of what I mean, but anyway, here we go. So now what this is saying here is that this angle here is 90 degrees. Anywhere you make an angle, let's go make another one just to hit the point home. I'm gonna go for the semicircle below. So even if I do one going down there like so, then the angle that is made at the circumference here, that's a 90-degree angle. So that's what this rule is saying, is that if you make angles in a semicircle, it's 90 degrees. Please make sure though, you don't misquote me when you're looking at this, yeah? The angle must be touching the circumference and it must originate from both ends of the diameter, okay? All right, good. Now we on to the next one. So on this next one, angles formed at the circumference between a tangent and a radius is a right angle. This is an easy one. So if I have a tangent going across there like so, and let's identify the center of the circle there. If I then make the radius come down like there, and it touches that tangent right where the tangent is touching the circle, then that makes a 90-degree angle. And I said radius or diameter because this could have well been a diameter as well. And if it was, then that's going to be a 90-degree angle. Notice the angle is not all the way out here. It has to touch right where the tangent touches the circle. The opposite angles of a cyclic quadrilateral add up to 180. Ooh, here's a new one I didn't tell you about, a cyclic quadrilateral. Well, let me start making a cyclic quadrilateral for you so that you can see what I am on about. So a cyclic quadrilateral, obviously it's in the name, it's a quadrilateral. It's got 4 sides, 4 corners. But a cyclic quadrilateral is a quadrilateral that is inside a circle, and all of the corners, all of these corners here must be touching the circumference. It must not cut the circumference. It must not be hanging outside here, or you can't have a corner that's just suspended in there. They must all be touching the circumference. This is a cyclic quadrilateral. Now, for a cyclic quadrilateral, the rule says the opposite angles add up to 180. So these 2 angles opposite each other, they add up to 180. So I can easily say that A plus B is 180 degrees. And I can also add another couple of angles in here. So let's call that C, let's call this D. And I can say, by the same token, that C plus D is also 180 degrees. And we know from other videos that the angles inside a quadrilateral add up to 360. So 180 plus 180 equals 360. Easy and done. Okay, so we're now coming to the last 2 rules before we look at a question. The angle between the tangent and the chord is equal to the angle in the alternate segment. What does that mean? Okay, so for this one, I'm going to have to do a little bit of drawing again. So let's start with a tangent first. Here is a tangent. And then I'm going to make a chord that starts from that tangent. And then I'm going to, so basically what you've got here, let's just demonstrate what we've got. A tangent and a chord. So what we're concentrating on is the angle that comes between the tangent and the chord. This is my angle here. It said it is equal to the angle in the alternate segment. And he's like, what is the alternate segment? Alternate segment just means the other segment, because I said at the top of the video that once you draw this line here, you're making two segments. You're making a minor segment and a major segment. And it just basically means that this angle is equal to the angle in the major segment. So let's just draw this angle in the major segment. And I'm just going to put that anywhere I feel like. So there it is there. And so this rule is basically saying that this angle here in this other segment plus this angle, well, not plus, this angle and this angle, they're both equal to each other. That's what that rule is saying. Notice though that the angle in the alternate segment has to start and end on that chord. Okay, so just make sure you keep an eye out for that. And when you're doing a complicated questions with loads of lines on it, you may find it difficult to spot that, but keep looking for it. And finally, okay, it says when two tangents intersect, they form an isosceles triangle. They also form all sorts of great things, and I've got a great question below to show you what happens. But let's just deal with this rule first. So I'm going to draw a couple of tangents here. So that's one tangent there. I'm going to draw this nice and long because I want to prove the point. And then I'm going to draw another tangent there, and those two tangents cross each other. So the point this rule is making is that when these two lines cross each other, what actually happens is that they form what is called an isosceles triangle. You will see the isosceles triangle if I then quickly stick a chord in there. And if I stick that chord in there where the chord touches the tangent, that's where my isosceles triangle will be. Okay, that took forever and a day, and well done for sticking with the video so far. So here we go. A, B, C, D are points on the circumference of a circle. Angle CAD is 62, so this is angle CAD, that's 62 there. ADB is 51, so ADB is 51, and it says find the size of angle ACB. So ACB is going to be this angle here. Now this one is really easy, and usually when you see these, they usually require you to give the reason for it, which is what they ask you in the second part of the question. So what do we know? Well, we already know that if I pull, let me just pull a line across there, thereby showing you I have a minor segment and a major segment. These two angles are in the same segment, so that means that they are equal. So I can now say that ACB is equal to 51 degrees. That's part one of the question. And the reason for it is angles in the same segment are equal. And that's it. That's literally how easy that question was. Now this one is my special question because it fits into that last rule I told you about, but there's something sweet about it. Okay, keep watching, don't miss this out. So A and C are points on the circumference of a circle, so I can see them there. It says that the center is O. That's good to know, because you know what, since the center is O, then that means that this and that would be the same, because they are the radius of the circle. Yeah, that's what makes this special. And since that's the radius and these two lines AB and BC are the same, it means that this is a kite. Okay, Didn't see that one coming, did you? So that one is a kite there. Anyway, ABC is 46, so we can see that that's 46 there. And it says find the size of angle OAC. So this is OAC. So in other words, what they actually want is just this little angle in here. Let me point it out. It's this little angle there. Okay, now remember I said at the top of the video that this is an isosceles triangle. Now with that being an isosceles triangle, all I need to do is find these two missing angles in there, and then it is going to help me to find that missing angle here. Now all angles of a triangle add up to 180 degrees, so I need to do 180 take away that 46, which gives us 134 degrees. Let's just write that as 46 if we don't mind. 134 degrees. Now because in an isosceles triangle these two bottom angles here are the same, which is going to give us 67 degrees. So that's 67 here and 67 there. Okay, so now I just want this little bit here. Now one of the rules we covered today says that if the radius come into contact with the tangent, it makes a 90-degree angle. And we can see that just here we will have that 90-degree angle. Let's draw it in. So that's going to be 90 degrees just there. So in order to find the missing angle, I need to do 90 degrees take away 67, which is 23 degrees. And so OAC is equal to 90 degrees take away 67, which is 23 degrees. And just like that, that is done. Now it says give reasons at each stage of your working out. Now I didn't write the reasons down, but when you're doing it for the exam, you must write it down. But in case you missed anything, I'm just going to say what the reasons are. So the reasons were angles of a triangle is 180. ABC is an isosceles triangle, so you need to write that down. It's isosceles. And then because it's isosceles, angle BAC is the same as angle ACB, which is going to be 67. And then you obviously write down the reason to say that when the radius meets the tangent, it makes a 90-degree angle there, and that's why you subtracted 67 from 90 to get 23 in there. So you need to write those down. All right, and the final question for this this video looks a little bit like a mean one, but it's pretty decent. So let's have a look. So A, B, and C are points on the circumference of a circle. Yes, we can see that there. It says that DCE is a tangent. Yes, we can see that there. AB is equal to BC. We know that because these two little lines already mean that those two sides are the same length. Angle BCE is 65. Yeah, we can see that there. Find the size of angle AOC. So that is AOC. So we'll need to do a little bit of drawing. So we just need to just stick that bit in there. And then we're looking for this angle AOC just here. This is a tangent and that is a chord. So I will need to use my angle between the tangent and chord situation to sort that out. So let's use it then. It means that, and let's actually do some working out, that angle BAC is equal to 65 degrees. And that is this whole angle here. That's 65 degrees there. And that's good to know because that's the angle between the tangent and the chord that gives me this angle here. This is an isosceles triangle. And if it's an isosceles triangle, it also means that this is 65 as well. Which means that if I add the two 65s, I get 130. And I take it away from 180 degrees to give me 50 degrees up here. Okay, so once I know that that's 50 degrees, then I can use one of the other rules that says the angle at the center is double the angle at the circumference. This is the angle at the circumference. This angle at the center has to be 100 degrees, 100 degrees there. Did you get it? Was that question all right? Would you have done it in a different way? Let me know in the comments below. Did you spot something that I probably didn't see? Again, let me know in the comments below. Anyway, for the sake of keeping you here too long, if you enjoyed this video, smash the like button. Don't forget to subscribe below if you haven't done so as yet, and ring that notification bell so you always know when an upload has been done. But for now though, until I see you on the next one, peace.